Again, somewhat similar to India's practical application, China is in the process of developing their own disaster mitigation and warning satellite constellation. This is a fairly new development. They are looking at establishing their own internal constellation of satellites specifically for use for disaster mitigation and response. China is an enormous nation. 200 million people in China a year are affected by natural disasters. And this is having an enormous human and economic effect on China. And so they have decided to develop a 6-year plan to develop 6 dedicated satellites to be used for natural disaster mitigation and monitoring. I don't know too much about this at this point, other than they say it's going to have less than 30 meters spatial resolution and be a combined optical and radar system as well. So we'll have to see what happens with this system as it is launched and developed. The Republic of China and Taiwan also has a space remote sensing capability. They had the French build and launch ROCSAT in 1999. 5-meter panchromatic, 15-meter multispectral, stereo capability. A second follow-on system with even higher spatial resolution, 2 meters, 8 meters. It was renamed Formosa. And you can see one of the images taken from it. So again, many different countries are getting involved in space remote sensing. Perhaps nations that you may not have thought were operating their own space remote sensing satellites. A very active nation in space remote sensing is Japan. Japan has been involved in space remote sensing since 1987. Again, just 1 year after the French launched Spot. They have a very active remote sensing program. They've launched satellites essentially every couple of years. They have a variety of different kinds of satellites, active and passive, various different spatial resolutions, and they have had a great deal of success and some failures. ADOS was their Advanced Earth Observation Satellite, very large, complex satellite, very capable, but unfortunately it had a failure early in its life, and that's one of the dangers you have of building these large, complex satellites. If you lose them, you lose pretty much everything. It had an 8-meter panchromatic image. Here we see the panchromatic image of the Hiroshima prefecture, and a 16-meter multispectral image capability as well. Very advanced technology design. The Japanese are very involved in space remote sensing for many reasons. Their latest is called ALOS, the Advanced Land Observation Satellite. It's scheduled to be launched in 2006. It's a 4,000 kilogram satellite, and again has a wide variety of different systems, somewhat perhaps like InVSat, in that it has a combination of a radar and high resolution and moderate resolution optical systems as well. So I hope you can see that we have many, many, many different kinds of space remote sensing systems. And if this lecture started to get a little bit redundant, there's a good reason for that, because an awful lot of these things look alike. They have similar characteristics. They have similar capabilities. And so some of the questions that arise from this is, why do we need so many of these satellites? Why do we have so many of these satellites that function the same? If we look at this next slide, you can see again, we showed this before, many of these satellites clump together in comparable groups. Down in the bottom left, we have the extremely high resolution systems that we're going to talk about in a further lecture, we have all these Landsat-like systems, we have radar systems, we have these wide area imaging systems. And what's interesting is, as I've showed you this slide before, essentially they're very, very similar. They're similar in characteristics, they're similar in orbits, they're similar in their data rates, they're similar in all of their spectral and spatial and radiometric characteristics. And so the question has to be, why are there so many of these systems? Why do they look so similar? And why are we spending billions, literally billions of dollars worldwide to develop and operate all of these systems when they essentially are redundant? And there are many reasons for this. One of the basic reasons is, of course, national pride. Space technology still has a certain panache to it, and for a country to be able to develop and operate and launch their own satellites has an element of national pride to it. But I think a larger question is also economic. There is a market for space remote sensing. People want to be a part of that market. They want to, they would much rather use their own satellites and their own satellite imagery rather than pay someone else from another country to utilize their systems. But I really think the real answer to why we have so many, if you will, redundant space remote sensing systems is the dual use nature of all of these systems. And by dual use, of course, I mean that they have civilian and military applications. All of these satellites and the data they derive have potential military uses. And the higher we go in spatial resolution, the smaller an object that we can see on the ground, the more military application that we have with these data. So I think the real use or the real reason why we see so many of these systems being developed concurrently is the fact that each of these nations around the world want to have their own native capabilities to develop and operate these satellite systems. So yes, they want to do environmental analysis, they want to look at forests and land cover and agriculture, they want to do disaster management, but in the end also that military capability really is very important. They want to be able to look at the countries near them with their own indigenous capabilities. They don't want anybody to be able to turn that satellite off in time of crisis. And so I think that's a major reason why we see so many concurrent satellites being developed. So, again, I want to thank you very much for joining me in this series. I hope you're finding it interesting. I'm certainly enjoying presenting this material to you, and now look forward to seeing you in our next segment. Thank you.